Okay, we're going to go ahead and start section 5.6 with this video. In this video, we start talking about complex numbers and imaginary values. Imaginary values or complex numbers are found a lot in like electrical engineering when you're dealing with impedance. So if you're going into an engineering field, you might see it. You'll see it in physics, work with it a little bit. But the idea is you get a square root of a negative number, and you guys have seen this before in your previous classes. We're going to work with it more and see how it applies to quadratics, and just work with some basic operations and how we work with imaginary values. So the first thing that we want to talk about is this thing called the discriminant. Okay, so right here, this discriminant is found by using what's underneath the radical in the quadratic formula. So I'm going to write the quadratic formula over to the right here, and it is negative b. Let me change the pen here real quick. It is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so what's underneath the radical is our discriminant. And that's going to tell us the type of solutions that we have. Not what they are, but allows us to classify them. And so you'll see at the rest of this slide here, we're saying, hey, let this be a quadratic, right? A can't be 0 because then it would be a line. And so we have three different distinctions here. We have the discriminant greater than 0. Well, that's going to give us two real solutions, because if the number, and that's what this is telling us, it's positive. If the number is positive, then our solutions are going to be real. We'll call this number 1. This one's number 2, but I'm going to skip this one and hop to 3 real quick. Number 3, because I'm going to graph these and show you pictures to what they look like. Number 3, less than 0. Well, it has 0 real solutions. They're actually going to be complex. And we'll talk more about complex values as the lesson progresses. But think about it. If it's less than 0, it's a negative number. What do we know right now about taking the square root of a negative number? You can't do it. Well, mathematically we can, and we'll talk about that. But that means there's no real solutions. Okay? And then going back to number 2, if it is equal to 0, then we have one real solution. And I just want to talk about this one real quick over to the right, because if we have negative b plus or minus the square root of 0 over 2a, well, what's left over? Negative b over 2a. That's only going to be one solution. That's actually our axis of symmetry, and what that means is our vertex is right on the axis of symmetry. Or excuse me, we have one solution. It's on the actual x-axis. So these are the three different situations that we have. What I'm going to do here real quick, we numbered them. I'm going to erase this. We're going to go ahead and I'm going to shrink this real quick. And we're going to go ahead and graph all of these guys to show you what the picture looks like. And so for the first one, if I was to graph a quadratic that has exactly 2 solutions, it would look something like this. It could open up or down, but we're seeing it cross in 2 different spots. So this is when the discriminant, we'll just say D. I'm going to erase that because that's getting too messy here. So this is a situation where the discriminant is greater than 0. Okay? The second situation, we're dealing with one real solution. So this, the actual vertex is on the x-axis, and that's what I was talking about before. So we had negative b over 2a when we plugged in 0. Well, that is the x in the vertex, which is on the x-axis in this situation. So this is when d is equal to 0. Okay? And then the third situation is when d is less than 0 or the discriminant is negative, we're going to have a graph, and notice it does not touch the x-axis. So we know that these solutions are non-real if we were to graph something and it did not cross the x-axis. So you can actually graph these guys in your calculator and you can determine what the discriminant value is. Well, if I get a picture like this one, well, I know that the discriminant is positive. If I get a picture like this one, I know that the discriminant is 0. And if I get a picture like this, I know that the discriminant is going to be negative, and my solutions are actually going to be complex in number 3. And then in the 1 and 2, they're both going to be real solutions. Let's do discriminant here. So we want to find the discriminant for each equation. Then we're going to classify or identify the number of real solutions. Okay, so we'll just start with A here real quick, and we'll do all these 3 real quick. The discriminant is b squared minus 4ac. So I have b squared, so negative 6 squared minus 4 times 3 times 4. So that's going to equal 36, and then we have 16 times 3. And 16 times 3 is 48. So that gives me negative 12. So there are no real solutions. Okay? So that's the discriminant, no real solutions. Let's hop on to the second one, or part B. So it's still going to be negative 6 squared minus 4 times A times C. Okay, so we have 36 minus, and then we have 4 times 9, which is also 36. So the discriminant is 0. There is one real solution. And then the very last one, we're going to do our negative b squared minus 4 times A times, not the letter C, it is C, but I got to put in 2. And that's going to equal 36 minus 24, which is equal to 8. So that's our discriminant, and there are 2 real solutions. So that's how we could apply the discriminant to algebraically or mathematically determine the types of solutions that we have. And we haven't talked about it yet, but no real solution means they are complex. And we'll get into that as we progress through the chapter.